All right, morning. It's a little bit hard to top off after Jensen and Ali. So we announced Databricks SQL, the private preview of it, about 4 years ago. And ever since, we've been humbled by reception. Databricks SQL became the fastest growing product in the history of Databricks. And today, over 7,000 customers worldwide, large and small, including Shell, AT&T, Adobe, are using Databricks SQL for their data warehousing workloads on Databricks. But one of the fundamental reasons why Databricks SQL has taken off so quickly really goes back to the idea of the Lakehouse itself. Before Lakehouses, here's what a typical enterprise data architecture would look like. You might have one or multiple of data warehouses for your business intelligence workloads and what I call looking back in time. And you have one or maybe multiple of your data lakes used by your data scientists, data engineers, and AI engineers for building machine learning models, looking into the future. And the two disparate stacks were really incompatible. They have different governance models, they have different storage formats, proprietary versus open, and that led to a lot of data duplication, data silos, and honestly, a governance nightmare. So when we looked at this problem a little bit over 4 years ago, we came up with this cute little term called the Lakehouse. And the idea of the Lakehouse is fairly simple at a high level. Let's marry the best of both worlds from data warehouses and data lakes and combine it into a same package. But the technologies weren't completely in place back then. We had to build a lot of stuff. We have to create Delta Lake for the foundational storage layer. We have to create a Unity catalog for the governance layer. But over time, the writing became on the wall that Lakehouses will be the future. And even proprietary warehouses started talking about Lakehouses. Forrester, a leading analyst firm, even come up with a whole new Forrester wave called the Lakehouse. And we're very proud, Databricks, by far the leader on the Forrester wave. Now, going back to data warehousing. One of the most important workloads on the Lakehouse is the ability to support data warehousing workloads. Databricks SQL is our product to support that. Many of you are among the 7,000 customers been using Databricks SQL every day. Some of you have never tried it. Some of you might have tried it 3 or 4 years ago and then formed your impression since. You might still have this impression that Databricks is great for data engineers, for data scientists, for the super technical people with PhDs in computer science, but not necessarily for all your analysts or your business users. But what we've really done is we've changed so much of the platform from every single layer that now the platform looks completely different. And to give you one example would be, when we first released Databricks SQL, it would take about 370 seconds to acquire a warehouse for compute. But today, that number is down to less than 5. So that's a more than 70 times improvement just in 3 years. And that's just one example. We looked at what are the most important fundamental areas, and we picked 3, and we really worked on every single inch of it. And this includes core data warehousing capabilities, out-of-the-box performance, and ease of use. Let's get started with core data warehousing functionality. Of course, to support data warehousing workload, we needed a lot of features and functionalities that were not available in the Lakehouse. We needed full ANSI SQL support. We needed materialized views. We needed role-based access control. These were not features that were available out of the box back then. So we built all of them. All right? And building on top of those, we now have built a very large data and AI partner ecosystem. So all your favorite tools were out of the box for data warehousing, and especially in the area of business intelligence. Tableau, Power BI, ThoughtSpot, Looker, Sigma, Qlik, all of those just work out of the box on the Databricks SQL. And this really substantially lowers the migration cost from traditional data warehouses over to Databricks SQL. The second area that we spend a lot of time on is price performance, or out-of-the-box price performance. And price performance is typically one of the most important evaluation criteria in data warehousing POCs. And for 2 reasons. One is data warehouses tend to be one of the most expensive, if not the most expensive, business systems out there. You spend a lot of money on it. To be able to save on it is essential to your operational efficiency. And the second is you want to guarantee all of your analysts and business users have the best experience. When Monday at 9 o'clock, all of them come to work, start opening their dashboards, thousands of queries hitting the data warehouse, you want to guarantee predictably low latency. So one thing I hope was clear from past data and AI summits is Databricks has always been really, really good at ETL performance. Last year, this is not a new chart. Last year, we published a study that would compare Databricks SQL versus a leading cloud data warehouse on how they would perform as we vary and grow data volume, data in size. So we grew from, so we started with 100 gigabytes, we grew all the way to 30 terabytes. And we just benchmark how well ETL performance work against these two different platforms. Initially, the two compare fairly similarly when the data set was small. But as you scale the data set, the economics of Databricks SQL really start to show because Databricks SQL scale roughly linearly in terms of cost, whereas the data warehouse scale exponentially. And it might sound surprising, but in practice, it's actually not that surprising if you think about it. The whole foundation of data warehouses were built to handle initially transactional business data out of OLTP databases, which tend to be relatively small. So the whole system designed from ground up to be really optimized for smaller amount of data. And when you do POCs, you typically don't load enormous amount of data into the warehouse. You grew your data over time. So they really try to optimize for the earlier stage. But in Databricks SQL, because we come from a more of a data lake heritage, we really make sure the whole system would scale far beyond 30 terabyte, even to petabytes range. Now, at last year at this conference, I gave a very different style of keynote. I gave a whole technical talk about how we're using AI systems to improve data warehousing engine performance. At the time, we knew AI would be something, but we didn't have any idea how big and how important it would be. In the last 12 months, we've revamped almost every single layer of our engine to incorporate AI systems in them. And this goes all the way from a bottom physical data layout, the middle layer query engine, and the top workload management, scheduling. And then we've really seen with our own eyes how much the AI systems can improve. And honestly, I think most of us, myself included, underestimate the impact AI system would have. Now, at this point, you're curious, hey, so tell me more. Show me the actual numbers. But before I do that, let me just show you a couple examples of things we've done to give you a little bit more concrete idea. And some of these examples might even sound abstract and difficult to understand, but that's OK. All right? The whole point is you don't have to understand all of it, but you can just see the benefit with your own eyes. The first example is Michael would tell you more about in the Delta Lake talk tomorrow about liquid clustering, which is a new fundamental breakthrough in data clustering. But on Databricks, we have built AI systems to learn based on your workloads and automatically actually suggest and cluster data for you. Not only does it suggest the type of columns you can cluster by, but it also actually decides, should it run all of the operations online as part of your ETL workloads? Should you get the fastest time to clustering? Or does it run it offline with minimum impact on your ETL workloads? The same AI system is also applied to statistics, which is one of the most fundamental ingredients in query optimization for warehousing. The AI system would actually decide what type of statistics do you need on different type of columns, how do you actually minimize the amount of overhead, do we apply higher fidelity statistics, or do we apply actually more sketches, depending on the type of workload you need. And one concrete example I gave you last year, for some of you that remember, is this thing called predictive I/O. And at the time, I joked about the term indexless indexes, which is very difficult to pronounce. The whole idea is predictive I/O applies a machine learning model to predict where the data would be and give you the benefit of indexing without the overhead, like read-write amplification of indexing. Thanks to the Mosaic AI stacks improvement over the last 12 months, we now can employ a model that's an order of magnitude larger in terms of parameters and feature vectors in predictive I/Os. So we just rolled out predictive I/O 2.0. This is not something you have to opt in. It just works automatically under the hood. But it can accelerate way more workloads beyond the simple selections I've showed you last year. So, OK, numbers. There will be a lot of numbers in the rest of the talk. You've all seen charts like this, a vendor showing some benchmarks and beating a competitor by a wide margin. Right? Every single vendor talk you've been to show that. I'll show you some talks, charts like that too. But this will be the first time, I bet, you've seen a vendor's own chart in which the vendor didn't perform favorably. So I think it's sort of conventional wisdom. If you have a PhD in Databricks optimization, you could get the best price performance out of Databricks one way or another. But what I really want to make sure is if you don't have time or you don't have that expertise to optimize your system, can you get the best performance out of the box without doing anything? So we created a synthetic benchmark exactly for that scenario, which is continuously ingest a lot of data. And then we run the TPC queries against them. And when we first did that benchmark in 2022, about 2 years ago, the data warehouse we benchmarked earlier was actually doing better than Databricks SQL. Last year, when we incorporated more of the AI capabilities, the two systems got to roughly on par. But something fairly magical happened last year, in the course of the last 12 months. As the AI systems evolve and become larger and larger and more sophisticated, and as they learn more and more workloads, it actually got 60% faster out of the box compared with 2022. And it now has industry-leading performance. And this is complete out of the box, no tuning required. All right. Now, some of you would ask, hey, you started the talk by talking about performance and thousands of analysts hitting the system, but that benchmark seemed to be about running individual queries. So we also created a scenario benchmark for the scenario really matter, which is 9 a.m. Monday, everybody opens their dashboard. In this benchmark, we created a bunch of robots that just keep hitting the warehouse using a variety of BI queries. Robots don't take coffee breaks, so each robot is probably like 10 times the normal human being. And we, again, just compare a leading cloud data warehouse versus Databricks SQL. When there's lower degree of concurrency, Databricks SQL and the leading warehouse would have roughly the similar low latency. But as we continue to scale and adding to 512 users, the difference really started to show. The warehouse had trouble scaling to the large number of users. And 512 robots probably simulate tens of thousands of users at this point, whereas Databricks SQL continue to deliver the same low latency. Now, some of you, actually, all of you probably also think, hey, I don't trust benchmarks to show, even though you say you simulate real-world scenario, but I really only care about my own workloads, my own real-world scenario. That's exactly what I told some of our engineering team when they showed me all these benchmarks. And I said, hey, I really only care about how our customers' queries would actually perform. So we took a stab at this. We looked at all the queries, all the BI queries that are repeating on Databricks SQL to establish a baseline in 2022, about 2 years ago. And we measured their performance over time. We track them for the same query, how well they're performing over time. And today, this year, in 2024, the same BI queries will run, on average, 33% faster. What does 33%, or 73% faster? What does 73% mean? A query that used to take 10 seconds now takes 2.7 seconds. It's almost 4x faster. And the best thing is, this is without you having to pay a single dime more, without you having to do anything. It's just the system getting better and better under the hood. And it's because how much you obsess and how much we know performance matters to you. The last part is of ease of use. Again, I said earlier, some of you have the impression that Databricks is great for data scientists, data engineers, but not necessarily great for analysts. So in the last few years, heard a lot of feedback. We revamped the user experience completely. But there's really no way for me to show you how much different you've gotten. You really have to try it yourself, right? The best I can do is show you a few screenshots that demonstrate the before and after. One example would be, hey, if you want to look at the data lineage or history, or of how data are created. In the past, you have to run a SQL query to get a tabular result. But this year, all you need to do is the system will show you visually how the entire end-to-end lineage of all the data sets, and not just for tables, also machine learning models. Error messages used to be daunting to the less technical user. Engineers might love it because they see stack traces, they point out exactly which line number have the issue, but it's very daunting to business users. Now we actually output a really simple error message, error codes they can Google. But even better, the AI models on the side would actually recommend and automatically fix the error for you. We also added a lot of quality of life improvements when it comes to SQL features themselves, beyond what standard SQL would give you. This is like SQL UDFs, lateral column aliases, session variables. All of these are features once you start using, you ask yourself, how come not every warehouse has this feature? What have I been missing out on in the last 10 years? But of course, what we really think we can leapfrog is through the use of AI. Databricks Assistant is extremely popular, has been extended to cover all cases of SQL. We introduced AI functions in DB SQL, so all of your analysts can now get the full power of off-the-shelf, both open source and proprietary large language models out of the box. But even better, your AI engineers can build a new model, publish it to Unity Catalog, and make it immediately available in DB SQL for all your analysts to consume. Same thing is applied to Mosaic AI Stack's vector search. DB SQL can now actually query the vector index automatically. Now, rather than me showing more about this, I would like to invite Pearl onto stage to show you a live demo of what all this looks like. Pearl.
Thank you, Reynold. So as Reynold shared, we're using AI to better your Databricks SQL experience by making the Lakehouse much simpler and more powerful. So right now, I'm actually in the SQL editor, and I have some revenue data for a few shops plotted as a time series graph. And this is great and all, but I would love to see what revenue could look like several months from now. Better yet, it'd be great if I could use AI to predict this. So I actually can with our AI functions. And I'm going to go ahead and use the assistant here to help me do exactly that. So I'm going to add a forecast through of September 2024. All right, so it looks like the assistant took my original code here, and it's unioning it with the forecast results, and it's doing that by just doing a simple function call to my AI forecast function. This looks good, so let me accept it and hit run. Just like that, I have my revenue forecasted, no Python or data scientist needed. But this revenue trend, it's kind of bad. And I definitely want to share this with the management team with their BI tool of choice, which is Power BI. So I'm going to use the assistant again here, and I'm going to create a materialized view that I will share to publish to Power BI. All right, assistant's hard at work. I'm going to accept that and hit run. So why a materialized view? Materialized views are really great because it accelerates queries, especially those that use AI for downstream users. OK, my materialized view is done, and it's actually a governed object in Unity Catalog. And I can search for it here. All right, let's go ahead and publish this bad boy to Power BI. As you can see, we have some offerings for Tableau as well. And I'm going to leverage the Databricks SQL Compute Engine. I'm going to direct query to Power BI. And this connection is made securely through my SSO login. I'm going to select all the columns here, build a column chart, let me resize it. And this can be shared with the management team now. So let's head back to the SQL editor and do more AI-powered analysis. So here I already have a query built out, and it's going to show me a bunch of Yelp reviews. And I'm actually going to go ahead and use AI query, which is actually an AI function here. And it's going to call a custom model that's going to build responses to those reviews. AI query is great because it also allows you to call foundational models like DBRX, but also external models as well. So here I have all my reviews along with the responses from my custom model, but I'm more focused on the reviews. I kind of want to see how people feel about our food and drink. So let me add a filter here. All right. Food. It looks like the filter gave me an exact match for the word food. That's perfect. Let's try drinks. There's no word match. But that's OK, because thanks to our new vector search function, we can actually search using an embedding model for related reviews in regards to drinks. And this is awesome because it doesn't have to be an exact word match. As you can see, I have brewed espresso, I have a rich cold brew, a brewed cappuccino. these are all drinks. So what the filter couldn't do, vector search can. So I'm going to build a parameter here. Databricks makes it super easy to do so. And I can easily search for reviews about any item. For example, here I'm doing pastries. All right, so we have all the reviews here, but I need to do a little bit more analysis. This is kind of a lot. So I'm going to use an AI function. As you can see, we have quite a few to choose from fixing grammar to translating text. But I'm going to use analyze sentiment to perform sentiment analysis on the review column. OK, let's run that. So this should give me another column that has a sentiment value on it. And it looks like it does. I have my review along with my sentiment. I literally just built a mini RAG in SQL. So now I'm just wanting to plot this so I can understand the distribution of sentiment. I'm going to hit save. And it looks like pastries has a pretty good reputation. But let me try service quality. The store will need to know this to improve if needed. And this viz makes it super easy. So it looks like service could definitely use a bit of improvement. Look at all those negative reviews. So to wrap, I shared with you how Databricks SQL's data warehousing capabilities allow you to query AI functions, call models, and make your data work for you. So with that, let's get to work. Back to you, Reynold.
Thank you, Pearl. All right, so in the last 4 years, we really revamped the entire experience of data warehousing. Databricks SQL today looked nothing like the Databricks SQL when we first released it. We implemented almost all of the core data warehousing capabilities so we can easily lowest cost migration over to Databricks SQL. We provide best-in-class out-of-the-box performance. And we also made it dramatically easier to use, so Databricks no longer just a platform for data scientists and data engineers, but also all your analysts. And all of this are really possible built by building on top of data intelligence stack. And when you combine, this is why we say the best data warehouse is a lakehouse. Because all of us would rather stay in the open, airy environment of the lakehouse rather than being trapped in a data warehouse. We feel a lot more productive like that. In this case, the lakehouse is also a hell lot cheaper than the warehouses. Thank you.